Good morning. Good afternoon. All right. Good afternoon. I think we can start. Couple of announcements. First of all, there's no school on Monday. Okay, no school on Monday, so don't go to any of your classes, okay? If anybody gives you a hard time, say your math teacher said not to come on Monday. Okay. Tonight, lesson 1-4 is due. So 11:59, lesson 1-4 is due tonight. And just a reminder that you have exam P3, P4 on Tuesday morning at 8 o'clock. Okay. So don't worry about coming to this session because we're taking a test instead. So the exam, 8 o'clock on Tuesday morning. All right. And the next time I see you will be on Wednesday. I think that's all I want to say. Yeah. So with that being said, what I've been doing most of today is just answering questions from 1-5 because there's questions about all kinds of stuff. The horizontal stretches and compressions. There's questions about even and odd. There's questions about everything. So I'm going to try to answer your questions. But before we get started, I want to talk about a couple things that have come up. Okay. Let's pretend that this is your answer. You cannot simplify this. This is simplified. So you can write it in slope-intercept form, but this is simplified. So the only time you would write it in slope-intercept form is if you're graphing. So if you were graphing, you would write this as 1/3 x plus 1 because it's just easier to graph in slope-intercept form. Now, if you're asked to verify, do not use this. It'll be harder. So if they ask you to verify, use this one. And like I said, you're going to always leave this answer unless you're graphing. Then you would convert it. We're not simplifying it. You would convert it to slope-intercept form. So why is there this confusion with simplifying? Well, let's look at this. This can be simplified because we can make it smaller. So all three terms are divisible by 2. So 2 times what is 4? 2. 2 times what is 6? And 2 times what is 8? That's simplified. This is not. All right, I hope that helps. All right, I'll go ahead and take your questions now. You guys want to ask me about anything?
Could we do number 12 on page 55 in the textbook?
12 on 55? That's in 1-4? Page 55, number 12. Normally I don't do these. Hopefully you're looking at your notes and you're collaborating because time, when we only have a short time in class, it is important that you try to ask me conceptual questions, but that's one thing that's frustrating about this class is that you're going to ask me to do problems and I'm going to say, I can't, we don't have time. It's a 30-step problem. I don't have time to do 30 steps. So I'm trying to get you to collaborate, trying to get you to talk to each other more. But we can't do long problems like this in class. So you've got to collaborate. I can answer conceptual questions, but we don't have time to work word problems in class. You can ask me some other time, we just can't work them in class. So I'll try to set it up for you. I'm not going to do the whole problem though. The label on a gallon of paint says it'll cover 250 square feet to 450 square feet, depending on the surface that's being painted. A painter has 12 gallons on hand. They give you an equation. So that's the area is equal to 12C. So it gives the area in square feet that the 12 gallons of paint will cover if applied. So this is the formula set up for you. Area equals length times width. And the directions at the top say, for the given function, determine the domain, then find an equation of the inverse. So remember what I said. When you're working word problems, all you do is solve for the opposite variable. That's all you do. Just like what I said. You solve for C in terms of A. So A over 12. So that is the inverse. Okay, the domain, if you read this problem, the domain, and you could draw a graph to look at this. You would input an A into A over 12 and output a C. The domain would be closed on 250 up to 450 closed. So the graph, you're going to have to do it. It's closed on 250 to 450. That's the domain. So the inverse function gives the coverage at which 12 gallons of paint must be applied as a function of the area. Anything else?
Could you show us how to do a composition?
Do you want me to verify my composition?
Yeah.
Okay. So what problem? I need two functions. So what problem can I pull off two functions? You want to do 9 or 10?
Can we do number 9 on the inverse of functions work?
Oh yeah. Well, on that one, all you had to do was find the inverse. You didn't have to verify. But we can verify it if you want. But on that sheet, all you had to do was find the inverse. Do you want to do one off that sheet?
Yeah, please.
Okay, let me find it. So if it doesn't say to graph, don't graph. If it doesn't say to verify, don't verify. So make sure you read the directions and do what the directions say. Okay, what number was it?
Number 7.
All right, so g of x is equal to 5 minus 2x. So I have to find the inverse in order to verify. So you're going to change f of x to y. You're going to switch x and y. You're going to solve for y, so subtract 5. That's a negative. Divide by a negative 2. Change it to the notation. Don't leave that negative there. So if you got a positive, the guys on the top flip, and I'm just going to write it as 5 minus x. So what I just did is the same as multiplying by -1 over -1. So that inverse, that's your function. That should be G inverse. So by composition, to verify, we're going to take f of g of x. Now, it doesn't matter what the letters are. The original function is this, and the inverse is that. So the original function is going to be f, and the inverse is going to be g. So that g is not this g. Okay, we're calling this guy f, and we're calling this guy g of x. So what you're going to do is you're going to bring the f function down and put in the g function. Well, this is the g function, right? It's simplified, 5 minus x over 2. Now we're looking at the f function. Well, isn't the f function 5 minus 2 times x? Right? 5 minus 2 times x, right? So the x now is 5 minus x over 2. Well, those 2's cancel. And don't forget to distribute the -1. So this would be a -5 and a positive x, which turns out to be x. So the other one, g of f of x, you're going to bring the g function down and put in the f function. Well, the f function, isn't that 5 minus 2x? So the g function is 5 minus something over 2, right? Well, what's the something? Right? You guys okay?
What
Or
is
no?
it? 3x? Or no, wait.
Here? Those are unlike terms. Those don't go together. This isn't 5x minus 2x. Is that what you're saying? I don't know who's talking to me right now because I can't see, but this isn't 5 minus 2 is 3. These are unlike terms. This is a constant and that's a variable. So you would say this is 5 minus 5 plus 2x over 2. So you get 2x over 2, which is x. So what we just did is we proved that what we did over there on the left is correct. So we proved what we did over there on the left.
Wait, Miss Birch. So for the verify on the f g of x,
Over here?
you know, yeah. So you know for the second step where it says 5 minus 2, yeah. So isn't that 5 minus 2x parentheses 5 minus x over 2?
Okay. What we're doing is we're taking the x out. Are you familiar with baseball at all? Do you know, like, you have a starting pitcher, and when you bring in the reliever, the starting pitcher goes out, right? Well, this guy right here, he's the starting pitcher. And we have to take him out and put the new x in there. So the x goes out and this new quantity goes in. Just like baseball. Do you see what I'm saying or no? All right, watch, Jacob, watch. Isn't this 5 minus 2x? So am I taking the x out and putting the new x in?
Yeah.
See, once you see it, it's a lot better. When you see it, you see it. So the function is 5 minus 2x. So you're taking that x out and you're putting the new x in. April,
Right.
did you follow it?
That helps a lot.
Yeah. April. Did you follow it or not really?
Yeah, no, I understood.
Okay,
Thank you.
no problem. Anybody else want to ask me about this while it's up here? Anybody have any questions about this while it's up? Now, if you're not comfortable writing it like that, you could have wrote it as G of F inverse, I'm sorry, G of inverse. The inverse of G. Where this was the G function and this was the inverse G function. I just wrote it like that because we're used to seeing it like that. Now, last period, people were complaining that the screen was blurry. Are you guys okay? I moved it up. So can you guys see the screen okay?
It just got blurry right now.
I know, yeah, it got blurry for me too.
Is it clearing up or no?
What works for me is if I reload the page and then join the call again, and it comes back clear.
Okay, can I erase this? Go ahead, other questions?
Can we do another verify one? For question, or for number, for find the inverse, do number, let's just say,
On that sheet?
yeah. Can we do number 6?
Number 6 on the sheet?
Yeah.
Okay, that's the H function, right?
Yes.
So we're going to find the inverse by changing h of x to y. You're going to switch x and y. And you're going to solve for y. So you're going to subtract 3 and divide by 2 and change y to the inverse notation, which would be h inverse of x. Now, I was just thinking about this. On my keys that I wrote, the key, I did that like at 11 o'clock at night. So I might have written F inverse. It should be, if this is h of x, it should be h inverse, right? So my key might be jacked up. I got to look at it. Okay, so this is simplified. And like I said, we're not going to split it up. We're not graphing. So do you guys want me to use H and H inverse, or can I change it to F and G?
F.
Okay. Who floats down? F, right? What is the G function?
X minus 3 divided by 2.
Good. All right, now, aren't we going to write down the F function? So isn't this the F function? Jacob, I'm putting that there for you.
Okay, thank you.
Because now we're going to take it out, right?
Mhm.
We're going to take it out and put the new x in. So what's the new x?
Isn't it the x minus 3 over 2?
And so since you're multiplying fractions, those cancel. And you get 3 plus x minus 3, which is x. And so now we're going to do g of f of x. And the g function floats down, and we put in, what's the f function?
The 3 plus 2x.
So that becomes the x of the g function. So what's the g function?
X minus 3 over 2.
But we're not going to leave that x in there, right?
No.
Aren't you going to take it out?
Yeah.
What are you going to put in there?
The 3 plus 2x.
Right? So we absolutely know we did this right. Okay, can you guys do me a favor and just unmute and let me know, yeah, this is more clear now. See, the more you do, the more clear it's going to be. So is this getting better or not?
Yeah.
Yeah,
Yeah.
during-
Getting better.
Yeah, it is.
Yeah.
Okay. Yeah, see, look what I did. And I can't go, I'm not going to go back and change. It was so much work for me to do this key and to put it in. But on every single inverse, I put F inverse. It's not F inverse. It would be J inverse of X, K inverse of X, H inverse of X. So I had to take pictures of all these pages and then make a Google document and string them all together. So I'm not going to fix that, but just know that those answers are all F of X. If you start with the H function, it's going to be H inverse of X. All right, anything else?
Oh, I actually have a question for the graphing one. For the inverse of functions for number 5. So I got it, but
What page?
first, yeah, number 1. The first page of inverse of functions.
4?
Yeah.
Go ahead. What number?
Number 5.
Okay. It says find the inverse.
Oh, okay.
So if it doesn't say graph, don't graph. Did you want me to do it or no?
On here it says find the inverse of each function, then graph the function and its inverse.
Really? Mine doesn't say that. Mine says find the inverse function for the given function f of x.
it says for me to graph.
On number 5 on page 53,
No, it's the worksheet. Practice inverses of functions. Practice problem solving AB.
oh, this one.
Yeah.
Okay. Yeah, I got to be clear which one you're talking about because I don't know which one you're talking about.
Yeah, sorry.
Okay, this says find the inverse. So let's find the inverse first. So you change f of x to y. You switch x and y. You solve for y, so subtract 10, and then you divide by 5. Now this is simplified, ladies and gentlemen. Don't go changing intercept form. This is a perfectly good answer, and it is simplified. Okay, now it says graph. So we do have to change this to slope-intercept form. So this would be 1/5 x minus 2. So the slope would be up 1, right 5, up 1, right 5, or down 1, left 5, down 1, left 5, and the intercept would be down 2. Now, did they say just graph the inverse? No, they want the original too. So we're going to graph the inverse right now, but then we have to graph the original. So the inverse is going to start at 0, down 2. I'm going to go up 1, right 5, up 1, right 5, up 1, right 5, up 1, right 5. I ran out of room, so I'm going to go down 1, left 5. So down 1, left 5, draw the graph. So that is the inverse function. Now, if we want to graph this guy, the slope is 5/1. So up 5, right 1, up 5, right 1, or down 5, left 1. And the intercept is 10. So 3, 4, 5, 6, 7, 8, 9, 10. And from there, we go up 5, right 1, up 5, right 1, 1, 2, 3, 4, 5, right 1, up 5, 1, 2, 3, 4, 5, right 1. And this doesn't look like the inverse. So something's wrong somewhere.
For the 10, it's actually a positive 10. Or
Over here? Or,
for the original, the f of x equals 5x plus 10. So if you're to graph it, want to be, for the plus 10, want to be like up on top.
okay, you see how that looks all messed up?
Mhm.
So that does not look like anything's been reflected over the identity. So something is wrong somewhere. So we changed f of x to y, we switched x and y, we solve for y, you subtract 10, divide both sides by 5. So this is right. This is 1/5 x minus 2. So the slope is up 1, right 5, up 1, right 5, or down 1, left 5, and the intercept is 0, down 2. So 0, down 2, and we're going to go up 1, right 5, or down 1, left 5. That looks right. So the blue graph, the slope is up 5, right 1, up 5, right 1, or down 5, left 1, and the intercept is a positive 10. The intercept is a positive 10. Positive, positive, positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's up there. So that's where the intercept would be. And then you got to go down 1, left 5. Do you want me to graph it again or no? But it's going to flip over the identity. I ran off the board. Do you want me to graph it?
No, you should be fine.
So you would start at 0, up 10, and go up 5, right 1, which there's no room. You want to go down 5, left 1, down 5. Let's see if I can do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to go down 5, like around here. Left 1, down 5, 1, 2, 3, 4, 5. Left 1. Yeah, it's kind of off. Should look something like that, though. But it should definitely reflect over the identity. So see how this reflects over the identity? You guys okay or no? Now, to be honest with you, most students understand when I teach you Algebra 2, what students get confused about is like this stuff in the Algebra 1. So that's what students are going to get confused about. Like my students will be able to say, I know how to find an inverse. Change f of x to y, switch x and y, solve for y, write the inverse. But what they can't do is they can't graph a linear function. So if you guys have questions, make sure you ask me. Can I erase it? Anything else you want to ask me about? Or well, let me ask you something. Look on page number 40, look on page 41. Do you guys know how to do 5, 6, 7, and 8? Yes or no?
Could we?
We can. That's a vertical. I'm more concerned about the horizontal, but we could do the vertical one if you want.
Are we?
So this says horizontal stretch by 3. Now that 3 makes sense. And that 3 is going to be used throughout the whole problem. The only thing that's going to look different is the function. So when you go to write the function, that's what's going to look messed up. Because it's going to look like this. right? But throughout this whole problem, when we do the point transformation, you're going to use 3. So give me some points off the original graph. Zero up to right 2, 0, left 2, 0, right? Show me what a horizontal stretch looks like with your hands. Okay, so these points are left 2, 0, 0 up 2, and right 2, 0. And horizontal, doesn't that mean X? And I said to do everything with 3, right? Aren't you going to multiply the X's by 3? So multiply the X by 3, multiply the X by 3, multiply the X by 3, and the Y stay the same. So this graph isn't really here. Erase it. And this says to go left 6, 0. It says to go right 6, 0. And 0 up 2. So does this look like it was horizontally stretched?
Yeah.
But the point I'm making with this problem is that everything we're doing is with 3, except the function looks wrong. So the function is the only thing that looks wrong. Notice too, this is not a quadratic. This is a general function. So it may look like a quadratic, but it's not. This is a general function of some kind. Okay, make sure you don't put these on the calculator because I can tell this is going to get harder, like way harder. And so I need you to be able to do these by hand. So that's why I taught you in that one sheet. I wanted you to state the transformations, show the transformational points and graph. Okay, this is not a calculator test. So make sure you're showing the point transformations. You got to get really good at these point transformations. These aren't always nice. Sometimes they're fractions. And so I got to make sure that you guys know how to do this very good. All right. What else? You guys understand
Could
odd and even?
you number 9?
Say it again.
Number 9 on 42.
Okay, they want to reflect across the Y. Now remember, reflection across the Y is a horizontal movement. See my arm? Okay, give me some points there that they gave.
Two to the left is 0, 0, 0, and then 2.
Right 2, 0. And then what? Left 1 up 3. And right 1 down 3. You guys are going to practice talking to me, right? Got to be able to say these ordered pairs correctly. All right, now, if we write down these points, left 2, 0, left 1, up 3, 0, 0, right 1, down 3, and right 2, 0. Isn't this a horizontal movement? So don't you negate the x? So this would be a 2. This would be a positive 1. This would just be 0, 0. Negate the x. Negate the x. And graph. So right 2, 0. Right 1, up 3. 0, 0. Some of the points aren't changing. Left 1, down 3. And 0, 0. And left 2, 0. So the original graph is dotted. Does that look like it was reflected over the y? Look. Yes.
Wait, Miss Birch, I'm kind of confused. Wait.
Jacob,
Hmm.
when you reflect over the y, it's a horizontal movement, so you negate the x.
Yeah. What does negate mean?
Like if I wanted to negate that, that would be negated. If I want to negate that, it would be the negative of -2, which is a +2.
Mm-hmm.
So to negate this would be -2. To negate that would be a +2.
Oh, okay. Okay, I got it.
It's actually a very good question, by the way, because nobody else understood what I was saying either, so. Maybe a couple other people. I shouldn't say everybody. You guys understand about even and odd? Do you understand how to do on page 43, 13, and 14?
Can we do one of the problems on 14?
Yeah. Now remember what even means. Even means reflect over the y. Symmetry about the y, right? Odd means symmetric about the origin, which means you have to flip it over the x and flip it over the y. Okay. Now let's use some common sense here. Now you have to show me mathematically because it's a math course. But let's just think about this. Isn't this a quadratic and isn't the parent even? Well, isn't this a vertical stretch by 5? Do you think a vertical stretch is going to change the symmetry? No. What's going to change the symmetry? Isn't it left or right? So now you're going to prove it. And what you're going to do is you're going to put in a -x and see what you get. So this would be 5 times -x quantity squared equals 5x squared. See how it matches it exactly? That means it's even. That's how you're going to show me mathematically. You're going to show that f of x equals f of negative x. That shows when these are equal, that shows they're even. Let's do another one. Isn't this a quadratic? What happened to the quadratic? Just tell me what happened. The parent is even. What happened to the parent? Come on, you guys. What'd the parent do?
Goes left 2. No, right
Left
2.
or right? Left or right?
Right 2.
So do you think
Right.
that messed up? Do you think that messed up the symmetry? Yeah, it messed it up.
Yes.
And I'm going to prove it. Watch. Those aren't equal. They're not exactly opposite. This is nothing. For them to be even, they have to be equivalent, and they're not. Now, I don't know about you, but that's a quadratic, but isn't this confusing? So I'm going to rewrite it. State the transformation. What's the quadratic?
Horizontal stretch.
Right, horizontal stretch. Now, do you think a horizontal stretch is going to mess up the symmetry of the parent?
No.
No, it's not. Watch. So this would be 1/3 times negative x quantity squared. So doesn't everybody have to be squared? So wouldn't this be 1/3 times 1/3 is 1/9? And a negative times a negative is a positive x squared. Well, that doesn't match, but does it? Watch. Isn't this 1/9 x squared? Are they the same? Isn't this x squared over 9? And isn't x squared over 9 1/9 x squared? This is even. So this is how you're going to mathematically see, because if you just write even, I'm going to think you copied somebody's paper, or I'm going to think you called somebody, or you're sitting next to somebody doing the test. So you have to prove to me mathematically how you know it's even. You're not going to just say yes or no. That's not good enough. Okay, let's do the last one. What is this? X, f of x. What's this doing to the parent?
Moving it up 6.
It's up
Okay.
6.
All right. Okay. So do you think that moving up 6 is going to change the symmetry with the y? No. So let me just reiterate. If you plug in a negative x and you get the same exact function, it's even. If you plug in a negative x and you get the exact opposite, like if this was a negative x squared minus 6, that's odd. And if you get like nothing, then it's neither. I'm not even supposed to be talking, huh? You guys are so cute. You guys weren't even going to interrupt me, huh? Because isn't class over at 2:05? You guys are so cute. I'm sorry. Okay, I'm sorry I kept you late. All right. I'll see you soon. Okay. If you want to hang out and ask me questions, that's fine. But I'm sorry I kept you late. My bad. My bad. Have a good day. Okay. Have a good day.
All right, bye, Miss Birch. Have a nice
Bye,
day.
guys. Have a good day. Thank you.
Bye.
Bye, guys. Have a good day.